there are theories now that suggest, as I mentioned, that there may be more than one universe and potentially an infinite number. It's a mind-boggling idea, isn't it? And I should say one extra thing. If that's true, then some of those theories say that what we call the constants of nature, so things like the strength of gravity, the speed of light, the masses of the particles, can vary from universe to universe. And then you ask the question, well, why is our universe so perfect for life? Why do stars make carbon and oxygen, the elements that you need for life? Why is everything so beautifully balanced so that living things can exist? The answer in these cases is because, well, every universe exists. Every possible combination of the laws of nature exists in different universes. So the reason we have to see a universe that allows us to exist, obviously. We could ask the question, well, how likely is that? Well, the answer, there are an infinite number of them, is it's inevitable, because there's every possible kind of universe. And I stress that this is very speculative stuff. But the first thing I said about inflation, the idea that there's this exponentially fast expansion before the Big Bang, if you want to use that language, that's not speculative. That's mainstream cosmology. But this idea that that may lead to multiple universes is more speculative. But it's still scientifically valid, and there are people who do research into that. And again, this is an active area of research.
Inflation tells us that the period of time before the Big Bang was extremely cold, and it was empty of everything but empty space. And that empty space carried energy that stretched the universe out to this enormous size, and into the initial state before the Big Bang. But there are also alternate theories to cosmological inflation, which tell us what caused the initial conditions that would eventually give rise to the Big Bang.
There's a theory there may be extra dimensions in the universe. So imagine that we're just living on a sheet of paper, let's say. Then there are theories where here's our universe floating around, and there can be another universe floating around. So there are more spatial dimensions, and we're just on a sheet floating around in this bigger multiverse. And then you can ask the question, well, what happens when they collide together? And one of the theories about what caused the Big Bang is that actually what it was two of these sheets, or brains they're called. So they collide together and separate. And when they collide together, they heat themselves up, and you get something that looks like a Big Bang on that sheet of space and time, if you like. So that's another different theory for what happened before the Big Bang.
Brains colliding into each other, giving rise to Big Bangs, multiverse theories, these statements might seem extremely speculative and out of touch with reality, but they do in fact have mathematical reasoning behind them. And moreover, theories describing the very early state of the universe do have experimental support.
So Stephen, everyone wants to know, what was around before the Big Bang?
Nothing was around before the Big Bang. According to Einstein's general theory of relativity, space and time together form a space-time continuum or manifold which is not flat, but curved by the matter and energy in it. I adopt the Euclidean approach to quantum gravity to describe the beginning of the universe. In this, ordinary real time is replaced by imaginary time, which behaves like a fourth direction of space. In the Euclidean approach, the history of the universe in imaginary time is a four-dimensional curved surface, like the surface of the Earth, but with two more dimensions. Jim Hartle and I proposed the no-boundary condition. The boundary condition of the universe is that it has no boundary.
Okay.
In order terms, the Euclidean space-time is a closed surface without edge, like the surface of the Earth. One can regard imaginary and real time as beginning at the South Pole, which is a smooth point of space-time where the normal laws of physics hold. There is nothing south of the South Pole, so there was nothing around before the Big Bang.
There can be no time and no space and no energy?
And no energy. Zero
and then
energy.
Suddenly, from nowhere and from nothing, comes something and somewhere.
And all sorts of stuff, and it sounds like the ultimate free lunch, and
yes,
it is.
It is.
It is, and it really, and what's remarkable is it's possible without any supernatural shenanigans. And
but listen, stop with that.
Why?
Why is what you're doing, whatever this is. Because, obviously, because I am not in the priesthood, I can't understand the scrawls on the blackboards you people down at, where are you?
Well, that's why I wrote the book, so you could.
Where are you? You're Arizona State.
Arizona State.
Okay, you priests of theoretical physics, you can explain to each other what you mean with your language of math, and I have to take that on faith.
No, in fact, you should be skeptical.
I am.
And in fact, you should, I know.